This 3D database table sits inside SAP S/4HANA's Convergent Invoicing environment. Focusing on a specific row, we locate the financial value for a customer's usage in the BIT amount column. However, the source transaction tag CCCIT reveals the price wasn't calculated here. That tag indicates this price was generated externally. It originated inside SAP Convergent Charging before making its way here into S/4HANA. And this single record is not alone. In high-volume industries like telecommunications or utilities, it is surrounded by millions of identical rows generated daily. At its core, SAP Convergent Invoicing is an ABAP-based financial subledger. It is built to organize and store these massive datasets for billing. SAP Convergent Charging, on the other hand, operates entirely outside of this framework. It is a standalone Java application. This gap creates a strict engineering challenge. We have to move millions of rated transactions from an external Java system into an ABAP database, and we have to do it without bottlenecking operations on either side. To understand how this price safely reached the subledger, we have to reverse engineer the invisible middleware layer that transported it, the Convergent Charging Bulkloader. We start by looking at the outer boundary of S/4HANA, the exact point where external data payloads first arrive. Here, an ABAP function module acts as the receiving gateway. Specifically, it is the FKK BIX bit create API. This function module is asynchronous. It takes the incoming payloads and places them into a queue, processing the data efficiently without locking up S/4HANA system resources. But this API is strictly a receiver. It does not actively pull data from outside sources. It waits to be called remotely. To make that remote call, the architecture relies on the SAP Java Connector, or JCO. Think of it as the physical translation tunnel, connecting the Java stack to the ABAP stack. The JCO allows the external Java system to reach across the technical divide and trigger the ABAP function module on demand. While the Java connector provides the transmission route, the data itself won't be accepted unless its structure is perfectly aligned before the transmission begins. To see how that alignment happens, we trace the route back across the divide into the SAP Convergent Charging Core tool. This interface shows a charged item class on the left. This represents the raw transactional data generated by the rating engine. On the right is the Billable Item class. That Billable Item class dictates the exact table structure required by Convergent Invoicing. The configuration step that links them is called Billable Item Mapping. It creates a rigid one-to-one alignment, like mapping a calculated price directly to the bit amount field. This guarantees that the computed price from the Convergent Charging pricing trees fits perfectly into the predefined slots of the S/4HANA subledger. By completing this mapping step in advance, the system avoids running heavy, processing-intensive data transformations while the records are actually in transit. On an administrative level, this mapping is shared across all catalogs in the Convergent Charging system, but activated per client on the S/4HANA side. But structural alignment is only half the battle. We still have to physically extract massive volumes of records out of a highly active rating engine. This diagram illustrates the internal architecture of the Convergent Charging Core server, showing the specific instances responsible for handling data: the dispatcher, the rater, and the bulkloader. The rater instances act as the core engines. They operate at high speeds, continuously calculating prices for incoming customer usage events. Because they are highly specialized for calculation, these raters do not attempt to transmit data over the Java connector themselves. Instead, the raters immediately drop their generated charged items as physical data files directly onto the local server file system. This is where the bulkloader takes over. It is a dedicated background instance that lives entirely separate from the rating engines. Operating on an asynchronous schedule, the bulkloader periodically wakes up to scan those local directories for new files left behind by the raters. When it finds them, it retrieves the files, applies that predefined billable item mapping to format the data accurately, and prepares a mass export. Finally, the bulkloader pushes these massive, perfectly formatted batches into the JCO tunnel, delivering them straight to the S/4HANA API. The bulkloader acts as a buffer. It completely isolates the mission-critical rating engines from the heavy lifting of database integration. You might ask why we bother with intermediate files and delayed batching. Why not write every event directly to Convergent Invoicing in real time? This top visualization shows a hypothetical synchronous architecture, where every single rated event triggers an immediate API call to S/4HANA. If you try to process millions of records per hour in a telecom or utility environment, this synchronous bombardment will quickly overwhelm the ABAP receiver. The resulting bottleneck forces the system to lock up, leading to severe performance degradation across the entire financial subledger. Now look at the bottom visualization. This is the asynchronous bulk execution mode utilized by the Bulkloader. It aggregates tens of thousands of individual records into one massive payload. S/4HANA receives a single clean block of data, executing one highly efficient database insert rather than 1,000 taxing microtransactions. This batched approach is mathematically viable at an enterprise scale, protecting subledger integrity while leaving the rating engine entirely unobstructed. Following the complete data pipeline, we begin with raw customer usage hitting the Convergent Charging rater for calculation. The rater processes the event and drops a charged item safely onto the local file system. The Bulkloader sweeps up that file and instantaneously translates the Java data structure to the ABAP table format using the Billable Item mapping configuration. It pushes the consolidated batch through the SAP Java connector tunnel, strikes the asynchronous ABAP API, and deposits the row into the S/4HANA database. By relying on a file-based batching instance as a buffer, SAP BRIM ensures that massive transactional scale never compromises system stability. When you configure a new service in this architecture, mapping the exact fields between the charged item and the billable item is the single most critical step to ensure this entire pipeline flows without error.